syllabus. As scheduled, today's topic is geometric modeling. The first geometric modeling agenda, and then we're going to move to some advanced 3D modeling and rendering techniques, mostly using 3D Studio Max next week. But today, I would like to introduce you some useful references for developing your final project ideas in terms of digital design. In lab exercise hours, we're going to tackle some 3D geometric modeling issues, especially for building modeling as an interior architect. So let's take a look at what to do today. To-do list here. Firstly, developing the final term project ideas, how to develop your idea. Simply, our baseline gonna be reviewing some good designs, good approaches for visualizing and developing your design concept. That's gonna be our bottom line, I told you last week. So we're gonna review some more useful references and talk about existing designs or existing proposed designs. And actually, today's lab exercises, 6 lab exercises, they are interrelated. So you need to submit actually just 2 max files only. For the simple floor plan building, we dealt with last week. And the College of Human Ecology, this building, level 5, for elaborating architectural elements. So we're going to review lab exercises in detail after the first hour lecture. In the meantime, while you are doing some lab exercises, I'm going to see you one by one for progress report using my progress Excel file. We'll show you later. And the requirements and what to do, what you have to submit, I list it up here so for your information. Okay, digital architecture competition like digital image is the subject of your final project. That is what you have to create, one single page for the final term project. All the requirements and what you have to do kindly listed up in this website, DA, for 2014. As we talked before, this one intended to be held next year, not this year. But anyway, for the final term project, you have to deal with some requirements and some development and some previous work award winners. You have to take a look at them, okay, using this website. This is one of the award winners for DA 2011, and it's the poster for DA 2012. Next, 2014's poster supposed to be using award winner of this DA 2012 anyway. The third session, digital architecture image, is your session of interest. You have to create very creative, student-generated architectural image for the future. That's a major concept, creativity. So please take a look at existing award winners and some references. Some Korean description for the competition, as well as the final project, just for your information. Again, I did this listed up again. Okay, this is review for the final term project, and let's get moved to today's lecture. For the lecture, instead of showing you some details in 3D graphics or geometric modeling, we're going to deal with that part in lab exercise hours and rest of our classes. But as continued pages from the last week, I would like to show you and share some ideas from good approaches, good design developments, and so on, using some useful and very recently announced examples. They are my references for you. For your information, FYI means for your information. For your information, I would like to introduce you animal peak illusions. This is an example of some kind of intended visualization of animal peak illusions. Actually, it has some different view when you see in different angle, but in very specialized angle, you can find out some designers or some planners intended visualization, something like this. How about this? This one shows you some red dots in this area, but actually it shows some different angle and different colored object like this. This is animal peak illusions. I'm not sure those two examples are real design. I think it's something visualization purpose instances. But how about this? This one is actual interior design project for Coca-Cola 125-year design. So amount of red paints on the wall, ceiling, and the posts. But in a certain standpoint, you can find out their logo and the Coke image, as well as some texts. This is real and actual project, and some description listed on the top. So this kind of specific visualization technique is kind of actual interior design element, but you can test, you can demonstrate something like this using 3D graphics software. That's why I would like to show you this part. And then, as continued pages from the last week, I would like to introduce you some more idea design book examples for developing your ideas and concepts. Idea and concept visualization. Let's take a look at how we can develop our concepts in terms of digital design. This is the book cover and the category the book provided: tower and group, box, polygon, circle, organic form. They are categories they defined in the book. We are actually in tower and group and box probably, and then move on to the rest of the categories. Some selective works that I want to show you and share you. Okay, this is the first one, probably within the tower category, the Scotch Tower. As you see here, this is a single high-rise building, and the building has its own visual concept anyway. So actually this one proposed by UN Studio, kind of one of the rising star architects recently anyway. Their visualization concept consists of some cloud top and some leaves and some kind of urban view. The area here is kind of getting some vista of urban view, as well as some nature view, sky view, and so on. As you see here, their rendering shows how this place works in the building like that. Anyway, that kind of connections or some inset space or some void area for making a kind of unique features of this building easily represented and delivered to the audience using this kind of simplified 2D and some picture-based diagram, so-called information graphics. This is kind of common and casual approach for representing your design. some kind of final rendering, sometimes very photorealistic, sometimes just architecturally drawn renderings and 2D or 3D images. But their concept diagram, infographic, usually 2D, because no shades or no sun paths or no shadow casting required for that kind of 2D infographic diagram. Simplified, easy, and intuitive delivery in terms of their concept, information, data. That's gonna be top priority. So that is why they represented something like that. Also, two more buildings, the kind of interrelated. The first one is single tower for that company, International Plaza, single tower proposal, and the next one is twin tower proposal. But actually those two different building plans have some tower building geometry as well as some non-uniform structure for this. Even if it's single tower, it has some kind of building attached bridge-like, some very unique geometric features, as well as some skeleton structure developed on the bottom like that. And the next one, those two buildings, usually twin towers, have very similar geometry. Mostly they are same. That is why we call they twin. But actually, this twin tower has very different geometric shapes. One is kind of typical glass cottonwood-based high-rise building. Another one looks like some kind of stacked box object, high-rise building. The major feature between those two buildings has some sky bridge, as you see here. So the major aspect you can find out from this kind of visualization is, at this time and the one before, single tower, those two examples rely on some realistic rendering. Even if it's not that photorealistic, that's fine. It's enough professional. I mean, it's looking professional enough because it's architecturally generated visualizations. So designer's intent should be represented in this kind of visualization style. Next example, rock magneton, designed by MVLDB and Cove. MVLDB is another very famous architect group, even 10 years ago, intended to be built in Denmark. As I told you before, those examples are some proposal, plans, idea design. No one knows, actually I'm not sure this building has been built or under construction or planned to be constructed, because they are just plans, just idea design, but done by very professional and kind of rising star architects. So MVLDB proposed this building, probably within the category box shape, but this one has very kind of unique building surface. Actually, we are not sure that what is the material for that surface, but its geometry is very triangular shaped and some kind of extruded surface. But my focus here is this infographic. Take a look at this 2D graphical representation. This is actually isometric view. So when you want to create this kind of visualization, the easiest way and intuitive way is drawing something like this using Illustrator or Photoshop or even by using PowerPoint. But actually when you design a model, when you create the model just at mass level, in lower LOD, level of detail, you can easily generate this kind of visualization using some hidden line removal method, even in 3D Studio Max, or some easy software, SketchUp. So hidden line removal software generates this kind of isometric view, some attached geometry development, or some infographic arrows, or some color fields, and some added on geometry. You can capture that kind of snapshot using Max or SketchUp, whatever, and some additional edits in 2D software such as Photoshop. So this kind of 2D concept development, concept diagram, so-called infographic, is very powerful and useful for displaying your concepts and your concept development, how you develop your concept. We can easily figure out the building mass for this one, thanks to that kind of 2D visualization. So this is fundamental and very common style, recently proposed projects. They are looking 2D graphic, but anyway, 3D software generated 2D and some edits. So 2D based simplified diagram, infographic, as well as some architectural or even photorealistic renderings. Next one also same. Simply imagine that you only have those two images. Interior side, you can figure out the material or surface structure, this kind of brick or some diagonally angled bricks stacked. And when you see this picture, this rendering, you can a little bit figure out the building mass or some style of that structure. But actually, this infographic, they put the title axonometric, but actually this is true axonometric, but it's kind of unfold, it's kind of deconstructed structure. So now we can easily figure out how this shape could be derived. There is one single box, but actually four, I'm not sure how many boards are there, but anyway, four boards, void space, gonna create that kind of interior shape. So we can easily and intuitively figure out the geometry of this building's interior. Of course, this picture also explains how this geometry looks like, but that line-based drawing axonometric diagram explains a lot more than that kind of renderings. So my suggestion, actually general suggestion for designers, 2D or 3D based 2D simplified diagram, infographic, as well as some realistic rendering shots gonna be kind of common and typical for architectural drawing. This example, exactly same structure. Some diagram, infographic, and some composed on top of some existing picture or some elevation view, very realistic rendering and visualization. The concept for this one is module. 36 modules for one container, for the one container. Each container has its own size, the same size, and some function. So Pink Cloud is another famous architect recently. They designed, actually they proposed this one named the pop-up hotel. And the size of the one single module, you can figure out compared to that container size. So total 36 modules, gonna be one truck, and 36 pallet gonna be alternatively combined in that way. So that one single shape also applied into the building elevation. The window size, or series of those windows for that curtain wall is exactly same to the structure of that. that single module. Next one is another example for modularized structure. There is another module named Instant House. Another title suggested by designers is Instant Lawn, intended to be installed Milano, Italy. But actually this kind of modularized house, modularized structure, housing could be delivered anywhere. As you see here, this module has some different style. It has vertical access. It has kind of 2 or even more floors in a single module. Very narrow, but kind of comparatively high-rise and some kind of tall structure compared to other single plan, single level modules. But anyway, as you see here, the bottom 2D line-based drawing generates this kind of infographic for describing how this module going to be working with for interior facility, human beings, even vehicles, and some airflow, circulation, and so on. So that is why they name it long. 폐. Okay, so I'm not sure the mechanical system or some mechanical aspect of this building function. But anyway, this module has its own circulation, airflow system, as like how lungs working. So this infographic, additional to the 2D graphical representation helps to visualize the concept and the function of this module. That's the point we have to take a look at from this one. Next one named Block A101. Okay, when we see this kind of blocked structure, we can see building's skin, building facade combined by amount of rectangle shapes. But it's not easy to figure out the building mass because this is one single snapshot of specific point. But when we see that kind of isometric diagram, infographic, we can easily figure out how this building mass is constructing, as well as this kind of modularized diagram. Designer intend to subdivide specific module like that way. I'm not sure how to read it, but anyway, specific distance, length, and width and height will be subdivided half, quarter, and even more subdivided objects gonna generate some post structure and some zigzag in three-dimensional ways. Geometric alternatives generate this building mass, and then facade design also applied for that kind of rectangle shaped modularized structure. So that is why this building looks like very typical, but it's not typical. It's kind of unique thanks to that kind of building mass. Okay, so 3D visualization is very powerful, but only for specific purpose. It's not that good for figuring out entire building mass or specific side or specific structure or function. We need this kind of general and 2D based infographic to show designers' intent in terms of geometric shape or functions or information flow or human circulation and so on. This kind of line-based drawing also generated from 3D Max, SketchUp, Rhino, whatever. Hidden line removal representation could be easily captured and derived from that kind of 3D software. And then we're going to bring them into 2D software for additional and further edits, modifications. Okay. Next one is Busan Opera House. The major aspects I would like to introduce you from this example is how they represent their major concepts. Their concept keywords are here: wind, wall, seats, and some bezel. The first important aspect from this building geometry is it's very simplified, very simple box-shaped building. But it has some LED, I'm not sure the technology for that, some surface has some media facade. Some media facade, media wall integrated into this building design for representing this, the uniqueness of this building design. According to the wind or some environmental factors, the screen gonna display very different visuals according to the situation or environment change. Another one is some kind of bottom, some base structure for this. This is a bezel, and this bezel has kind of containers, hundreds, even thousands of containers. So the building mass consists of this kind of modularized containers. But anyway, the container bezel gonna take this kind of some water surface, ocean surface, thanks to the weight of that bezel, as well as some cloud and some rocks on the sky and some stacked containers. Anyway, we can easily, intuitively recognize that that is kind of bezel geometry for that building box. So their concept has been successfully represented in this kind of 2D and 3D representations and diagrams. So referring to those well-represented visualizations going to be really useful for creating and developing your concepts. Next one, named iceberg. When you see this building representation in 3D, we can easily find out building facade or building unique structure or some visualizations in the wall, on the wall, and some interior aspects. But this is actually some kind of 2D hand drawing or some similar techniques for representing this building geometry. Originally, that was some kind of rectangle shape, but cut it off using some triangular shape, some cut corners. Take a look at this rectangle shape. Some cut corners, and they can be erected 90 degrees so that they can create some triangular shape. So that kind of alternatives gonna generate this kind of building facade and building mass. So now we can figure out the entire building building mass. So we could realize that this was looking kind of triangular shape because its elevation looks like triangular shape, but originally it has rectangle geometry thanks to that kind of infographic representation. Actually, that kind of concept development sometimes not that important, but for designers, it is very fundamental and very useful for getting more detailed ideas and developments. Additional diagram displayed on the bottom. And next example, a mosque for all. This is kind of regional space for specific religions. But take a look at this diagram. When you see this building, what do you feel? How you can figure out the building mass or some geometry? This one has some void space, a kind of open area, open space. It looks good and looks fine. It looks kind of well and good designed building. So 3 different mass and some nicely represented interior, providing some open space. Looks nice, but actually this one derived from this kind of dome structure. There is a dome structure for religions. Amount of people gonna get pray in this kind of dome structure. You know, this kind of religional buildings in Europe. But think differently. Invert the geometric structure. So this is kind of enveloped space, but now we have some open space thanks to other buildings enveloped. So we can get this kind of dome structure thanks to 3 different mass. Kind of inverted shape, and I think this one generates very unique and kind of well-designed approach for making that kind of open space, open area, right? So that kind of even very simplified 2D diagram, sometimes it has really powerful visual representation because we can easily get how this geometry was derived from. And now we can understand the title of Mosque for All is kind of very well entitled because it's open space, not enclosed dome space. Some religions, people enclosed to exterior world, but now we have some kind of open space. That is why this religion is kind of open to all. Okay, I think this is very unique and very nicely represented design proposal, I think. Okay, the next one, the last one. Also, this one looks like some typical box-shaped building, but actually it's triangular shape mass. But the same as the one that I showed you before, originally it was very typical rectangle shape. But we can try to rotate exterior geometry, not interior, so that you can, okay, the zooming in and zooming out, make those 2 points into one single point, and some rotated rectangle gonna get some different geometry, corner cut geometry, so that it's another triangle shape, and some alternatives will generate in that shape, some rounded rectangle, rounded triangle, and some rounded and some counterclockwise turning of the interior shape. So total 4 triangular shape generated in that way. Very simplified rotation gonna make this kind of building shape and some additional design concepts in terms of its geometry. So that is why this building has some rectangle shapes. But anyway, originally it's another primitive rectangle. Okay, but different rotation of interior and exterior shapes. That's the geometric concept for this building. Before getting into the lab exercises, we need to take a look at some geometric modeling issues, especially using 3D Studio Max for handling editable poly and so on. And today's topic is something overlapped from the last week. Last week we reviewed how to build actual building. But this week we're going to review some part of that building modeling as well as some advances. Okay? So hopefully we can get into some built environment based modeling and rendering issues this week. So before getting into some 3D animation making and some advanced features in renderings and some Photoshop or After Effects based further developments after the rendering, and some advanced features in geometric modeling and so on. They are on schedule, but today, as the last week of geometric modeling, we're going to deal with some building geometry and building modeling using two different CAD files. Okay. Okay, take a nap and get back to the course in 10, 15 minutes, okay?